Good morning, math fans. Today we are going to start our journey through the world of data. Data collection, data representation, different types of graphs, and how those graphs could mislead you into drawing inaccurate conclusions. Before we can jump into that, we need to be able to identify different types of data. There are two of those that we're going to talk about. The first one is qualitative data. Now, inside the word qualitative, you can almost hear the word quality. That's what this data does. It identifies some type of quality about a group of things. We are going to use names and labels rather than analyzing a whole bunch of numbers. Now, there are two types of examples for these. We could have the labels, or we could have numbers. But Ms. Graham, you just said that we're going to use labels instead of numbers for things. Well, give me a minute. We'll get there. When we talk about labels, we're talking about gathering data on maybe eye color, or favorite food, or maybe the type of car you drive. Could be your best subject in school, book you liked the best. We can get all kinds of data along those lines. The other one that I said we were going to take a look at is qualitative data still, but we're going to look at numbers. Now, these aren't numbers that measure anything. These are numbers that signify a category of things. So, for example, we could look at jersey numbers for a sport. We could look at zip codes. We could look at social security numbers. All of these things involve numbers, but these are numbers that serve as categories. The second type of data we're going to take a look at is quantitative data. In here, you can almost hear the word quantity. These are pieces of data that are going to measure or count things. So maybe we measure age. We could measure weight. We could measure height. Or the time it takes to take a test. There are lots of others that we could use. Those are just examples. Notice that these will all have units. So we measure age in years. weight in either pounds or kilograms. Height is usually feet in inches or maybe centimeters. Time for testing we usually measure in minutes and hours. So all of those things have units. Inside of our quantitative data, we have two types of quantitative data. We have discrete data and continuous data. Now, discrete data is not numbers that can keep a secret. Discrete data is data that involves the counting numbers or the whole numbers. So examples might be the number of books you read, or number of speeding tickets. You could have number of people. These are things that you would not use fractions or decimals to measure. So that is a big quality right there. No fractions or decimals. Continuous data still uses the whole or the counting numbers. But there's always a but in math. You get to use everything in between also. It's all numbers, not all hashtags. So continuous data uses whole or the counting numbers, but you also get to use all of the numbers between them. So this includes all of the fractions. And the decimals. Count. These are things that involve partial measurements. So volume. You can drink half of a 1 liter soda. Speed. It is possible to travel 53.4 miles per hour. If you watch a baseball game where they clock the speed of the pitches, sometimes you'll see decimals there. Time is definitely a good one. Rarely do we spend exactly 1 hour or exactly 2 hours involved in an activity. Typically, we spend 45 minutes, 3/4 of an hour, or 30 minutes, half an hour doing things. So those are continuous values. Down at the bottom, we are going to identify each type of data as qualitative or quantitative. If it's quantitative, we're going to tell whether it's continuous or discrete. So let's go through all of them, and then we will come back and deal with continuous and discrete as necessary. So A says, a survey of favorite colors among your classmates. Well, colors is definitely not a number. So this is going to be qualitative. The number of books read. This one, since we're talking about how many books are being read, this is quantitative. And I'm going to put a little star back here so that I remember to come back to it. 3 says the commuting distance. Now, you can drive 43.5 miles. That is a number. So this is also quantitative. Zip codes. Oh, we need to come back to 3 also. Zip codes. These are numbers, but they don't measure anything. These are categories. It's like a bucket. I'm from NAC, so I'm not familiar with the Panola zip code, but in NAC we have 75965, and I think there's a 75961. So we could make a bucket with those labels on them and dump names of people who live in each zip code into those buckets. So this is qualitative. So now let's go back to our 2 quantitative sets of data and decide whether they are discrete or continuous. Our first one was the number of books read during a summer reading program. Now, typically we don't read 1.5 books. We read 2 books, or we read 4 books, or we read 13 books. The point is, we read a whole number of books. So this one is discrete. Number 3, distance. I think the example I used was that it was 43.5 miles from my house in NAC to Panola College. So 43.5 uses a decimal. That makes it continuous data. That is the end of our brief introduction to data. Stay tuned because next time we will take a look at how to collect all of these types of data.